Position, velocity, and speed. Let's start with position. And I want to show you a pictorial representation. And I'd like to do that with a number line. So let's say we have an object that starts at position of +2. We'll call that position A. And then it moves to the origin, or 0. We'll call that position B. And then the object moves to a position of -3, and minus meaning negative direction, so perhaps to the left. We'll call that position C. And lastly, to a position of -4, we'll call that position D. And this is, we're going to call position the variable x, and the unit for that will be in meters. Now I wanted to show you a tabular representation by having a table. So in our table, we can represent the 4 different positions of A, B, C, and D. We can write when position A is represented by a positive 2 meters on the number line. Position B is at the origin. C is at -3, and D is at -4. And lastly, we just can fill in at when is this happening. So let's put in some time values. So the first 2 meters starts at a time of 0. Position B starts at a time of 2 seconds. C at 4 seconds, and D at 6 seconds. Okay, now I want to show you a graphical representation of position. It's actually position versus time. I want to go ahead and plot the points from the table on the graph with the color green. So position A starts at a time of 0 but a position of 2. So that happens right here, and that's A. And there's B, there's C, and lastly, there's D. And in connecting the points, we have a graph that looks something like this. So here's your graphical representation of position versus time. Okay, now let's talk about displacement, which is basically a change in position. Now, the variable or the symbol for displacement is a delta x, and that's equal to your final position minus your initial position. If we wanted to know the change in position in my previous example, say from point A to point D, we would take my final position, which happens at D, minus my initial position, which happens at A. And plugging in numbers, I would have a final position of -4 meters minus a +2, which gives me an answer of -6 meters. So my displacement would be -6 meters. Now that negative indicates position to the left or a negative direction, or we'll just leave it like that for now. But I do want to add that if there's a direction value in your answer, which in this case there is, to the left, so to speak, we say that this is a vector quantity. And we will be talking a lot about vectors in this class. So just keep in mind that this is a vector quantity. Now, different from displacement is another term called distance. And distance really just looks at how far have you traveled. We don't want to look at a change in position from where you started and where you ended. We just want to know your total distance, or what was the length that you traveled. Now, distance is different from displacement because it is a scalar quantity, which means the answers will always be positive and we're not interested in direction. I do want to give you a little example here. Let's say we have some object here and it starts at position A, and it moves in some squiggly line path around, and it has a distance. Let's say it ends here at point B, and it has a distance that includes the path which it travels. Now let's say I wanted to know the displacement, which is just looks at where the object started and where it ended. And the displacement would only be a measurement in blue between points A and points B. So the distance value, which considers the whole squiggly path, is in black, and the displacement is in blue. Distance is a scalar quantity. I'm not interested in direction. And displacement is a vector quantity where my answer not only considers the change in position, but also the direction. So let's look at another example between distance and displacement. So let's say I have a circle here, and some object starts at point A. We'll call that point A, and they travel around the circle counterclockwise, and they end where they started. So they started at point A and they end at point A. Now, what is the distance that this object traveled? Well, there's a radius to this circle. We'll call that R right there. But the distance is going to be equal to the circumference of the circle, which is just 2 pi r. But the displacement, on the other hand, which is a change in position, is going to be the position it is at where it started, the final position, it ends at A, minus the initial position, which is at point A, and that's equal to 0. If we're using the unit of meters, that would be 0 meters. Okay, now let's talk about average velocity, or define average velocity. So in this class we will be writing average velocity with the cursive lowercase v with the subscript of AVG. The SI unit for average velocity is a meter per second, and there is a formula for average velocity. So V average is equal to your displacement, or your change in position, over your change in time. That's equal to your final position minus your initial position, all over your final time minus your initial time. So that's average velocity. We're also going to put in, let's see if I can fit in here, a little subscript of x, because later on we will be talking about other things like v sub y's and v sub x's. So right now we're just going to give this a subscript of v sub x, and that it's an average. So let's look at another position versus time graph and see if we can find the average velocity throughout this graph. And let's start with the average velocity between points A and B. So my Vx average is going to be my change in position between points A and B divided by the change in time between points A and B. And it's going to be my position at point B minus my position at point A, all over my time at point B minus my time at A. So at B I have a position of 1. At A I have a position of 0. The time at B I have a time of 1 second, and at A I have a time of 0. So I'm going to get an answer of positive 1 meter per second. Now that positive value means an object moving in the positive direction. So velocity is also a vector quantity. Average velocity is a vector quantity because it gives me direction. Now let's take a look. Let's see if we can find the average velocity between points B and C. Okay, so that's going to be the position at point C minus the position at point B, all over the time at C minus the time at B. Now the position at C is a -1. The position at B is a +1. The time at C is 2 seconds, and the time at B is 1 second. So I'm going to get an answer here of -2 meters per second. Notice here that I have a negative. This negative is very important. This negative means between points B and C, this object is moving in a negative direction. It might be defined as left or down or south. And because of that, we say the velocity is a vector. Now for number 3, I'd like to find the velocity between points C and D. Notice there that there is no change in position. So my average velocity in the x direction is just going to be, well, let's write it out. It's going to be the position at D minus position at C over the time at D minus the time at C. Now the position at D is -1. The position at C is also a -1. The time here at D is 3 seconds. The time at C is 2 seconds. What I'm going to get is in the numerator I'm going to get a 0, and the denominator I'm going to get a 1, and that does equal 0 meters per second. So when your position doesn't change, you're at rest, or you have no velocity. Now, what if I wanted to know the average velocity between points, say, A and D? On the graph, that would look something like this. So hopefully you can see my purple line there. And when you look at that line, you see that we have a negative slope, a slight negative slope. And the slope of this line turns out to be the average velocity, or the velocity. So using our formula for velocity, let's go ahead and see if we can figure out what that value would be, and if it comes out to be negative, because my negative slope here indicates it should have a negative velocity or moving in a negative direction. Okay, so for solving for my average velocity in the x direction in this case, I'm going to have the position at D minus the position at A over the time at D minus the time at A. Now the position at D is a -1, and the position at A is is 0. Excuse me, 0. The time at D is, what is that, 3 seconds? And the time at A is 0 seconds. So working this problem out, I get a -1 over 3. So it's -1/3 meters per second, or 0.33 meters per second, and there's a negative in there. So that negative worked out. We were correct because of that negative slope in the graph. Alright, now let's define average speed. The symbol for average speed is still going to be a cursive V to the AVG, but I'm not going to put a little subscript of x here this time because I'm not interested in direction. Speed is a scalar quantity, so there will be no little subscript of x. The formula that it's written in most textbooks is that your distance traveled over your change in time, or your total distance traveled over the time to make your trip or to travel that distance. I like to write it as a Greek letter sigma, capital sigma, which just means total. So it's your total distance traveled over your total time. And again, this is scalar, so I am not interested in direction. I'm only interested in the answer with the unit. And when we talk about an answer with the unit, the term for that is magnitude. So I'm only interested in the magnitude, which means my answer will always come out to be positive. Alright, let's do an example. All right, let's say you have someone traveling in a car, and at first they travel a distance of 5 kilometers to the east for 20 minutes. Then the car comes to a red light, so it doesn't move any distance for 3 minutes. And then the car goes 3 kilometers south for 10 minutes. And my question to you is, what is the average speed for the whole trip? Now, V average is just total distance over total time. So let's see if we can figure out what those are. So the total distance, just by adding 5 kilometers, 0 kilometers, and 3 kilometers, I get 8 kilometers. And for time, I have 20 plus 3 plus 10, which gives me 33 minutes. So I'm going to plug that in to my equation here, 8 kilometers over 33 minutes. So that gives me 0.242 kilometers per minute. Okay, all I need to do now is just convert my answer to SI units. All right, let's cancel some units. And there you have it, 4.03 meters per second. So let's look at graphing a little bit more. And this is a position versus time graph. And I want to compare direction, distance, displacement, average speed, and average velocity at different places on this graph. So first let's look at between points A and B, and let's start by looking at the direction. So the direction between points A and B has to do with the slope of your line. So if you're looking at a position versus time graph and you have a negative slope, that means that this object is moving in a negative direction. So we have a negative direction. Now the next thing we want to look at is what is the total distance traveled in between A and B. Well, in this case it looks like we're going from 3 meters and we're going to -3 meters. So that's a total distance of 6 meters. Turns out the displacement in this case is the same as the total distance. Sometimes displacement and total distance are the same, but not always. But in this case, the displacement is 6 meters. Well, there is a difference here, and the difference is that it's -6 meters. So I stand corrected here. And the negative means that the object did move 6 meters, but it moved 6 meters in the negative direction, so that is very important. This next column here, which is the average velocity, which looks at your change in position over your change in time. Using the formula here, we're going to have a -3 minus a +3 over a time of 2 seconds minus a time of 0. Now notice this is the same thing as finding the slope of segment AB. So the slope is your average velocity. So my average velocity is -3 meters per second. Again, the negative telling us that the object is moving in a negative direction. The average speed, my last column here, which is total distance over total time, is just going to be the 6 meters divided by the time of 2 seconds, or a +3 meters per second, just meaning I'm not interested in the direction when we're talking about speed. I would like you to make your own chart and fill in the answers for segment BC, CD, and for AD. That one will be a little bit more interesting. So let me go back up to the graph so you can refer to the graph. But I would like you to fill in these boxes based on the graph above. Here it is. Thanks for watching.